So we're going to be doing the composition substitution, one of the substitutions you can do for differential equations, also known as obvious substitution. So what we're going to do is first we're going to divide by x plus y on both sides, and isolate so that it's only dy over dx is equal to 1 over x plus y. So what we're going to do is, of course, we're going to do some substitution. So in all the substitution methods, you usually have something known as v. So we're going to set v. So here, we're going to set it, think about something, usually it should be something in the form of like x plus y plus c, of course, or x minus y, something like that with like the addition of two variables. So we're going to say x plus y in this case. Then what we're going to do is let me just rearrange just y plus x is equal to v, and we're going to minus x on both sides. So, this is going to say y is equal to v minus x. And we could say the derivative of this with respect to x, well then derivative of v with respect to x is dv over dx, and the derivative of x with respect to x is just n1, and then because negative 1, because subtraction sign. So now we can plug in all this back to here. So we know that dv over dx minus 1 is equal to 1 over v. We'll add 1 to both sides. So we get 1 over v plus 1 is equal to dv over dx. This right side, if you make this the common denominator, you have v here and over v here. So this becomes v plus 1 over v is equal to dv over dx. And then times dx on both sides. And then times by v over v plus 1 on both sides. So this of course will just cancel. This just cancels to 1. So this just becomes v over v plus 1 over dv is equal to dx, basically 1 dx. So we do the integral with respect to, so on the left side respect to v, and then the integral on the right with respect to x. So this is just going to be equal to the integral 1 dx, that's just with x. Then we're going to use our c here, constant. Now this one, we can split this v over v plus 1 into partial fractions. So we're going to say v plus 1 over v plus 1 minus 1 over v plus 1. So remember the same thing as that. So right side is just the integral of v plus 1 over v plus 1 is 1 minus 1 over v plus 1 dv is equal to x plus c. And then we can integrate this, so this just becomes, well, we're doing with respect to v, so this is be v, and it's v minus, well, the integral of 1 over v plus 1, that's just going to be ln of v plus 1, like that, and that's going to be equal to x plus c. And then remember what we set v equal to x plus y, so this just becomes x plus y minus ln v plus 1 equals x plus c, and then we can cancel the x's on both sides, so we can get y minus ln, sorry, this should be x plus y, so this becomes x plus y plus 1 is equal to c, and it'll be pretty hard to go from here to make this even more simplified, so I believe you can just leave it in this form. So I'm going to try to do a video on embedded, so yes, this is a solution problem. So yeah, I'm going to try to do embedded and reducible second order in my next two videos, so thank you.